for the power functions. If you can figure out several significant power functions in the future, you can extend your understanding to more complicated power functions. First, let's take y equals x. Please observe this expression. If an equals 1, x raised to n, here n is 1, so this function should be 1 times x raised to 1. It will be x. So we get this function. You know this function is a linear function. In the Cartesian plane, you can easily figure out its graph. All right, it should be a straight line. For this function, you know, you can use several key points to locate this function. That is y equals x. Next one, y equals x squared. All right, here an is 1, n is 2. So we get this projective function. In the Cartesian plane, you will get the function it should be like this. You can use several key points to locate this function. All right, that you say here 2, 4, here negative 2, 4, and this point 1, 1, negative 1, 1. And this point is also on the graph of this function. So you can connect the key points to figure out the graph y equals x squared. Okay, next one, y equals x raised to 3. All right, here, if we use the same Cartesian plane, we can sketch its graph. Of course, this point, this graph, this origin should be on this graph. All right, and this point is also on the graph of the cubic function. Next one, if here it is 8, you know the point should be 2, 8. Here, if this is negative 2, the corresponding y coordinate should be here. All right, so negative 2, negative 8. Then you can connect the graph. It should be like this. All right, if you want to get more accurate graph, you should use several points. You should use more points to locate this function more accurately. All right, so this is y equals x raised to 3. Next, in the same Cartesian plane, we want to discuss y equals x raised to 4. All right, you know, for this expression, of course, 0, 0, that is the origin, must be on this graph. If x equals 1 for this function, the y coordinate is also 1. So this point and this point is also on the graph. But for this situation, that you say x coordinate equals 2, the corresponding y coordinate is not 4. It should be 16. All right, 16 should be here. And simultaneously, if x equals negative 2, the y coordinate should be positive 16. So if x equals negative 2, the corresponding point should be here. All right, so you will get these points and these points if x coordinate equals positive 2 or negative 2. So you can get the function. It should be like this. All right, it should be like this. But for this domain, you know, these numbers are less than 1. That you say, for example, if this is 1 over 2, for this function, the y coordinate should be 1 over 4. But for this function, the y-coordinate should be 1/16. So if the x-coordinates are the same, this point should be above this point. So if x-coordinates are less than +1, the points on this graph should be lower than the points on this graph. All right, so it should be like this. Then you can get the graph. You can get the graph like this. All right, this is y equals x raised to 4. Okay, that is it. Here it is flatter. It is flatter than this graph on this function. All right, this is y equals x raised to 4. Next, if x raised to 5 in the same Cartesian plane, all right, we can get the graph should be here 1, 1, 2. If x equals 2, the y-coordinate should be 32. If x coordinates equals -2, the y-coordinate should be -32. So the graph should be steeper. Y equals x raised to 5. All right. Next, if x raised to 6, y equals x raised to 6. In the Cartesian plane, you know the function graph over this domain, the graph should be much flatter than this function. All right, so it should be like this. All right, we use this graph to demonstrate the graph of this function y equals x raised to 6. Okay, for these significant power functions, you must be proficient with their graphs in the future. For the more complicated questions, you can use the basic properties of these functions to analyze the more complicated functions. All right, and we will further discuss the end behaviors of these several significant power functions.